Hello, today I will try to show you how the indestructible PowerShift gearbox works in the case Magnum. The gearbox consists of two parts. The first part, on the engine side, contains 7 clutches. Then, the second part, on the axle side, contains 3 clutches. These are the medium range, low range, and high range clutches. These clutches are switched every 6 gears. Between the first part and the second part of the gearbox, there is the main clutch. It is an 8-plate wet clutch. It is used to start the tractor moving. Furthermore, this system is essential to effectively stop the tractor's movement. The specialized odd and even gear shaft remains permanently and securely connected to the engine's crankshaft through the use of a high-performance torsional vibration damper and heavy-duty bushings. This critical shaft then continuously transmits the mechanical drive power further along the line to the hydraulic pumps and the integrated PTO shaft system for various agricultural operations. The intermediate shaft has gears that are permanently connected to each other. It transmits power to 3 clutches, clutch 1, clutch 2, clutch 3. It does not transmit power to the 4th clutch. The 4th clutch is for reverse gear. The clutch baskets are permanently connected to the shaft. However, the gears are designed to be freely movable relative to the central shaft. When the discs are firmly clamped together, the shaft's rotational power is effectively transmitted through the system to the gear. To move the tractor, the condition that must be met is that all 3 clutches in the gearbox must be engaged. The clutch must be engaged on one of the odd or even gear shafts, as well as one of the 4 clutches on that shaft, and the clutch in the second part of the gearbox, medium, both the low and the high ranges. Additionally, the main clutch must also be fully engaged. We select gear number 1, the low-range clutch assembly, located within the secondary section of the gearbox unit, as well as the corresponding odd gear clutch mechanism are both currently engaged and operational. It effectively transmits mechanical power from the primary shaft directly to the odd gear wheel and then subsequently to the intermediate shaft. Through this specific intermediate shaft, the rotational drive is then carefully transmitted further along the system to. With clutch number 1 fully active, the internal discs are engaged and we have successfully selected gear number 1. When we move to select gear number 2, the first basket clutch assembly remains engaged. Only the internal shift mechanism transitions from the odd gears over to the even gears. This ensures a smooth and seamless transition between the different gear ratios during operation. The rotational drive is transmitted directly through the even gear wheel to the intermediate shaft. And then, via that same intermediate shaft, the drive is transferred over to basket number 1, where we have gear number 2 located. When we select gear number 3, clutch number 1 is fully released, while clutch number 2 engages. And on the shaft containing both the odd and even gear baskets, the process continues smoothly. The even gears are released while the odd gears engage. Then the drive is transferred to the intermediate shaft and to basket number 2. At that point we have gear number 3. When we select gear number 4, the basket remains engaged, but the change occurs on the shaft with the odd and even gears. Moving over to the even-numbered gear sets, the rotational drive is efficiently transmitted through the even gears corresponding gear wheel assembly, directly to the intermediate shaft, and then onward to the secondary clutch basket number 2. At that specific point in the process, we have successfully engaged gear number 4. When we select gear number 5, the second clutch is released and clutch number 3 engages. And on the shaft with the alternating sequence of even and odd gears, it changes from the current state. The even gears are disengaged from the drive and the odd gears are firmly engaged into position. Then the rotational drive is efficiently transferred through the mechanism to the intermediate shaft and we have gear number 5. When we select gear number 6, the third clutch basket assembly remains fully engaged in its current state, but on the shaft with the odd and even gears, it switches over to the even gears, and that is exactly when we have gear number 6 successfully engaged. Whenever we decide that we want to select gear number 7, the specific clutch located in the second part of the gearbox system switches over from the low range to the medium range. Following this transition, the odd gear clutch is then fully engaged, which effectively transfers the drive through the intermediate shaft and over to basket number 1. Once basket number 1 is successfully engaged, we then have gear number 7 ready for operation. Moving forward, when we select gear number 8, the basket itself remains engaged, but on the internal shaft, the system switches from the odd gears over to the even gears. The drive is then transferred via the intermediate shaft directly to basket number 1, and at that point we have successfully reached gear number 8. Finally, when we select gear number 9, basket number 1 is completely released, and basket number 2 is subsequently engaged to complete the process. Looking closely at the main shaft, specifically at the odd and even clutch baskets, the drive mechanism is first switched over to the odd numbered gears. And then we move into gear number 9. When we proceed to select gear number 10, the clutch basket remains fully engaged, and it then smoothly switches the drive over to the even numbered gears. Finally, when we select gear number 11, the system continues this precise sequence. Clutch number 2 is released and clutch number 3 engages. Looking closely at the odd and even baskets, we can see that the specific clutch for the odd numbered gears is currently fully engaged. When we proceed to select gear number 12, the basket assembly remains firmly engaged, and the system then smoothly switches over to the even numbered gears for operation. Once the transmission reaches the 12th gear, the high range clutch mechanism fully engages and the entire sequence of clutch switching operations begins to repeat itself in the exact same order as we observed previously. Consequently, by utilizing this specific combination of 6 individual gears multiplied across 3 distinct ranges, the system effectively provides us with a total of 18 separate forward gears for operation. How do the reverse gears work? The intermediate shaft is meshed with the primary gear wheel of the first basket, and it also connects to the second and third baskets. This ensures that the rotational force is distributed evenly across all 3 components. However, it is not meshed with the gear wheel of the fourth basket, which is responsible for the reverse gears. The gear wheel of the reverse basket is meshed with the gear wheel of the even gears, which causes the direction of rotation to change. Of the shaft with 4 baskets, when we select the first reverse gear, initially the hydraulic system ensures that the clutch plates within the reverse gear basket are firmly pressed together, which is immediately followed by the engagement of those located in the odd gear basket. Once this engagement is complete, the rotational power is efficiently transmitted from the primary input shaft directly to the odd gear wheel. From there, the energy flows steadily to the intermediate shaft, then continues its journey via the intermediate shaft to the even gear wheel, before finally reaching the reverse gear wheel to complete the transmission cycle. When we select gear number 2, the clutch assembly for the odd-numbered gear basket is gradually released, while at the same time, the clutch for the even-numbered gears is being fully engaged. At that specific point in the process, the mechanical power is transmitted from the main drive shaft directly to the even-numbered gear wheel, as well as to the dedicated reverse gear clutch assembly. As we proceed to select both the third and the fourth gears, the specific clutch located within the second section of the transmission gearbox assembly undergoes a shift from the low speed range over to the medium speed range. And during this process, the reverse gear clutch is once again fully engaged, along with the engagement of the odd gear clutch mechanism. Consequently, the mechanical power is transmitted directly to the intermediate shaft and then flows onward to. In this specific stage of the mechanical process, the rotational force is directed toward the even gear wheel and then flows seamlessly into the reverse gear basket wheel to complete the necessary engagement for the system. When we select the fourth gear, it seamlessly transitions the transmission from the odd-numbered gears over to the even ones. And then we have engaged fourth gear in the reverse direction. How does the crawler gear reducer work? Located specifically on the intermediate shaft, right at the very bottom section, there is a specialized clutch mechanism that engages the reducer. This particular clutch receives its rotational drive directly from both the even and the odd gear shafts simultaneously. When we manually or automatically engage the reducer clutch, the mechanical drive is then transmitted directly to the intermediate shaft. At that specific point in the sequence, the standard odd and even gear clutches do not operate at all. Instead, the drive power passes through the small gear and the large gear assembly to reach the reducer clutch on the intermediate shaft. And then finally, the individual clutch plates for the first and second gears are fully engaged to complete the process. And third gear, as well as one reverse gear on the reducer. Next, the ranges change in the second part of the gearbox, and then we have additional gears on the reducer. In the next part, I would like to show the gearbox control and the electrical part. Thank you for your attention. Best regards.